Good morning, everyone. Today I am going to talk about graph theory in AI pathfinding in computer games. In many games, characters move automatically and find the best route to reach a destination. This smart movement is done using graph theory and pathfinding algorithms. So next we have introduction to pathfinding. Pathfinding means the best path from one place to another in a game. For example, when an enemy follows a player or when a character walks around the obstacle, games like PUBG, GTA and Minecraft use pathfinding. So the character move intelligently instead of randomly. So next we are going to discuss about fundamentals of graph theory. Graph theory is a max concept used to represent connections. In a graph, we have nodes and edges. Nodes represent the locations and the edges represents the path between locations. Some paths may have different cost, like long distance or difficult terrain. So next, we are going to see how game maps are converted into graphs. In games, the map is converted into graph structure. Important positions become nodes, and the path between them becomes the edges. This helps the game AI understand the map and find the best route. Next is graph topology in games. There are different graphs used in games. Grid graph divide a map into small squares. Navigation meshes divide the map into walkable areas. These help characters move smoothly in a real-world game. Now we will look at some algorithms that helps the AI find the best path in a graph. The first algorithm is breadth first search or BFS. Breadth first search checks all nearby paths first. It explores the map step by step. This method helps to find the shortest path in a simple map. Depth first search or DFS goes deeply into one path before trying another. It is useful for exploring areas like maze, but it may not always find the shortest path. Next, we have Dijkstra's algorithm. It finds the shortest path when we have different cost. For example, walking on a road may be faster than walking through mud or water. The next algorithm is A-star. It is the most popular pathfinding method in games. It predicts which path is closer to the destination and chooses the best route quickly. Because of this, it is widely used in modern games. Now we are going to compare these algorithms. Each algorithm has different uses. BFS works for simple maps, DFS for exploration, and Dijkstra for weighted paths. A-star is the fastest and the most commonly used in modern games. Now we are going to look at a case study of Pac-Man. In the game Pac-Man, the maze can be seen as a graph. Each path is connected like a network. The ghost uses pathfinding logic to chase the Pac-Man inside the maze. The next is the case study of Unity engine. In Unity engine, maps are converted into something called a navigation mesh. AI characters use A-star algorithm to move around the obstacles and reach the destination. Now we are going to see the impact on game development. Pathfinding makes the game character more realistic and intelligently. It helps to avoid obstacles and improve the overall gaming experience. So let's see trends in pathfinding. In future, the games may use machine learning and smarter AI to improve the pathfinding and make the character behave more naturally. To conclude, graph theory helps game AI find the best path using algorithms like BFS, DFS, Digistrax, and A-star. This makes the modern games more realistic and interactive. That's all. Thank you.